I don't know if participants can see that as well. Yeah. Okay, I don't mind. I can continue with that. Okay, so where we are. Oh, okay. So back to this. So what is AraSAS? So AraSAS is Arabic Semantic Analysis System software that provides full semantic tagging text in Arabic, and it uses hierarchical semantic tag sets of 24 major discourse fields and 232 fine-grained semantic field tags. So this is basically based on the English semantic and now multilingual, which is called USAS, which is Lancaster University UCRL semantic tag, which I'm going to talk about later. But so far, it does 15 languages, and Arabic is one of them. And so if you go to the website, you can find more details about other semantic taggers and lexicons, as well as the Arabic. Okay, so what prompted work on Arabic semantic taggers? So there's been a lot of work on Arabic recently and in the past decade, but still we still lack tools that is needed for Arabic semantics. So enrichment morphology in Arabic is different from other languages like English and European languages. So one of the challenges is the large number of attached clitics, so prepositions and pronouns that attach directly to the word. So optional use of diacritics is also making it a bit challenging because we don't have enough diacritized text. So other things like short vowels and termination, like Shatha, which is combining two letters into one, is also making this a bit difficult and challenging for Arabic. Okay, so I'm going to talk about an example that was used by Nizar. So Nizar is one of the co-authors. So if I made a mistake, you just wave there and tell me to correct it. So the word was, I think, walain, and it's just trying to say that, trying to like morphologically analyze this word, come up with different kind of forms and different meanings. So just the word ayn actually has more than 50 contextual meanings, and that's just on its own tells you the complexity of Arabic when it comes to semantic. And I couldn't put all the 50 of them, but I just put a sample just to show you that ayn actually could mean it could mean spring, rain, sun, envy. Most of those I didn't actually know, so I'm learning. So if you want to know about all these semantical meanings of the word ayn, you can take a screenshot of that QR. It will take you to the Mujam al-Maani, I think, and it gives you more details about it. Okay, so the corpus we use in this work is called ZIPUP. So it is Said Arabic English Bilingual Undergraduate Corpus. So this is a bilingual corpus created by Zayed University as part of an assignment to undergraduate students who are bilingual, so they speak English and Arabic. And we divided that into a corpus split into two. We're gonna call that the English subcorpus, the Arabic subcorpus. So basically, in some cases, the same student write the same topic twice. In other cases, the student might write different topics, one in English, one in Arabic. But either way, we've got the same student writing in two languages. So it helps if you are from the linguistics background to do L1, L2 comparisons. From our background, it's good to see if there's a difference between the type of speakers, because we know the gender as well. So that can be like used in order to analyze the semantic tags given to the corpus. Okay, so this was part of the degree to assess their language skills. So I'm not the judge. Someone actually expert judged that and told the student whether this is good or not by giving them a score. And for us, it's actually used as gold standards resource to increase understanding of text through machine learning and NLP in the future. Okay, and it helps in widening the support of both comparative research studies of Arabic from an English perspective. So if you want to access the corpus, again, take a screenshot of this QR codes. I'm going to do this at least 5 times more, so be patient. So you can actually access that at any time. You can email me and I'll be happy to send you the links. Right, so there was an attempt to AraSAS in the past. So just to make things simpler, I'm going to call them AraSAS 1 and AraSAS 2.0. So these are, or this one is the first attempt. This was never released, not because of anything. There was some kind of restrictions about the copyrights of some data used. So the authors used Buckwalter Arabic Morphological Analyzer to compile a list of Arabic lemmas, and this was this as well include what we call English glosses. So basically the translations of each Arabic word in English. So if you can think about it now, because we have a complete English semantic tagger with a complete lexicon, so all we did is, or they did, is actually match the glosses, the English glosses to the English semantic tagger. So basically given the semantic tags given to the English word to the Arabic, and you can tell that this is not always working well, so it will still need post-editing by human experts. So the authors managed to find 71% match of those lemmas. The process, of course, was error-prone due to the out-of-context meaning. So you're just saying, this is the translation, here's the equivalent, but you're not taking any semantic into consideration. There's no context in there. But that resulted in more than 37,000 entries. Only 4% was post-edited, meaning that a human expert went through that tiny amount of data and checked them, fixing any errors in the semantic tags given. So the new modified version is called AraSAS2. So this provides extended and edited semantic lexicon. But most importantly, it's open source. It's available on GitHub. And we're so happy that it is now connected, integrated with Camel tools, thanks to Nizar. And also thanks to researcher Elvis de Souza, so from Brazil. So Elvis was really helpful in developing the tool, integrating it with Camel, and also working with researchers through Nizar. And again, QR code if you want to download Camel tools, access it to GitHub. But here's the coarse grain semantic tags, what we call the major discourse fields for USAS. So basically this was built for English and then kind of translated or integrated within other languages, but it stayed the same. You might tell me later that we need one for Arabic, which is true that so far we worked with that one. So each of those letters actually relate to something. Like P is education, obviously P is E. No, I'm joking. So all of those actually go down into fine-grained ones, 232, I think, in order to have like subcategories or sub-semantic levels. So this is the pipeline for our AraSAS. So it was developed in Python 3, and it also included other Python libraries. So you start with Arabic text, you use syntax segmentation using NLTK, then Camel tools jumped in order to do like tokenization and lemmatization. And again, you get the Arabic semantic tagger, which is AraSAS, and then there will be an AraSAS database lexicon that we're going to use in order to tag the words. So I shouldn't say this, but since there's a QR code, so if you want that access to try AraSAS, so please click on that one. It might show you all the languages, but Arabic is one of them now. And you can try it using the form. Basically, you can try the demo, or you can go back to the GitHub and download the code yourself. But basically, this is one example from the sentences provided by the students. تشهد دولة الإمارات العربية المتحدة تطوراً كبيراً. And then the translation that we added in just to show you what that means. But basically, we tokenize segment. What that was segmented anyway. It's a sentence, but it tokenized into words, do some like analysis. But you can see there's the English gloss, there's the part speech tag, the lemma, and you can see an _1, which I'm going to explain in a minute. And here's the semantic tags that we've got. So as I said, the capital letter is the major semantic. Then you get like subcategories like S, and then S9, A, and so on, until you end up with something like punctuation in that case. You'll see pluses and minuses. So I think Paul there is the best one to explain what those are. So maybe ask him after the talk, but I think it has to do something with usage, or maybe I shouldn't say. I think just ask Paul after the talk. You're looking at Al-Muttahida. Okay, so United. So what is the meaning of S5 and A1.1? So I don't memorize it, so I'll have to see if Paul knows, then he can help us. And then I can give him 2 minutes. I'll come back to that. Yeah, so there is a long list. So if you go back to the USAS website, so we've got the explanation of all these major tags and then the subtags in them and what each one of them means. What does the pluses and minuses? Yeah, so the same major categories work across languages. That's what I meant at the beginning, that you might need something more specific for Arabic. So far we don't, but we might need to. It was translated to other languages. We've got, yeah. So S5 is groups and affiliations. So that makes it, and there's A1.1.1, and it's general action. Okay, yeah. So, and the pluses, minus? Is it like killing is negative and love is positive? Okay, thank you. Yeah, I knew that. I just wanted someone to confirm. Okay, so well, creating RSS is not just the code itself, so you have to create the lexicon. So for the lexicon creation, we had an amazing help from Nouran. So Nouran is a PhD student at Leeds University. She's a linguist. She helped us a lot working with Elvis in order to create the Arabic lexicon. So we started with the draft from the AraSAS 1. The shortcoming there, of course, was the use of reduced basic representation of Arabic lemmas. So to help fixing that, we used Camel database, which is based on Bama and Sama, and that helped like AraSAS to distinguish different meanings of lemmas with numbers, number marking. So you get like an ID underscore. So you get like work underscore 1, 2. I can make up things, but I think Nizar is the best to answer that. So you can ask Nizar about those after the talk. Sorry, keep like assigning tasks here, but no. All right, okay. Sorry. Okay, so I've got 5 minutes. I might sound like I'm rushing, but I think that's my speed. So Camel tools database is based on Sama 3.1. Got more than 42,000 lemmas with IDs, part speech tags, and corresponds to 37,000 basic lemmas, no IDs, and more than that with part speech tags, which is obvious because you get more part speech tags given words. I'll skip that just to show you the creation process of the lexicon. So that's what Nouran did. So started with the AraSAS 1 lexicon list of lemmas, so matched that against an Arabic tree bank lemma list, updated the list of lemmas, then used lemmatization from Camel, match with the English, use as through clauses, add the IDs whenever needed, and then finally you get like the AraSAS 2 lexicon. So the lexicon is also available online to download. We've done some validation based on 2 steps. The first steps, we compared semantic tags of the first 1,000 lemmas in AraSAS 1 with AraSAS 2. Areas where significant difference found included both lemmatization and semantic tags. And then there was some manual modification of the first 1,000 lemmas that include either adding or removing semantic sense and rearranging previous senses. And here's an example of what happened in AraSAS 1. So these things were merged. You have no differences because there's no context. So you get more semantic tags, which is not really accurate, although it increases recall, but it's not really accurate in terms of precision. But in AraSAS 2, because of this ID usage, we can have 2 kind of meanings of Ali or Ali. If it was a name, you get a proper noun, and if it was like an adjective like supreme or high, you get different set of semantic tags. So this example tells you exactly the improvement that we've done in AraSAS 2. There were some issues, of course, with validation because of untagged words, and those words like pull them out of vocab for now. So it could be either transliteration, someone actually writing house in Arabic, or television, or like it could be proper names in other languages like Roland, or spelling words like orchestra is written like orchestra, which could happen. So these led to like no matching to the list we've got. And again, this was followed by manually analyzing 10,000 lemmas. Thank you, Nouran. That was assigned what we call a Z99 tag. So basically Z99 means no match. So Nouran went through those to make sure that this is the case or isn't. And we found that most of those 1,300 were either personal names, geographical location, or other proper names. And I've got 1 minute. In order to evaluate that, we've done some kind of coverage using 2 other data sets other than ZBook. So one is a news data set and another blogs just to see what is the coverage in that one. So we've got like a really good coverage compared to the English. The English one goes beyond 99 point something. For Arabic, we got 96 for blogs and 96.8 for news, which is good results. But again, even though with high coverage, this is not the evaluation you're looking for as an NLP person, of course. But for us, this is just a way to introduce USAS in Arabic, basically AraSAS, that can be used. So we're relying actually on our previous knowledge and evidences from evaluating USAS. This is my last slide. I just put it in there just in case I have time, but just to show you what we can do. So this is graphs from ZBook. So you've got text in Arabic, text in English, and then what semantic tags each of those are getting. And then we've got text in Arabic, text in English for male, the pink ones, and females, the green ones, just to show you, like, do they agree on the semantic tags? Do they have differences? And that if you're doing linguistics kind of comparison, L1, L2, it is very helpful to see like what changes your way of writing if you are L1 speaker, L2 speaker, or the opposite. And that's it. Thanks a lot, everyone. Do anything?
Questions?
Okay. I can see someone saying QR is not working. There were 6 QRs. I can't tell which one.
So from the virtual attendees, do you have any questions, please? You can raise your hand or write it in the chat. I barely hear you, Engineer Hamdi. Can you?
We are still waiting for questions from the audience.
Okay. So I don't see any questions from the chat or from the attendees. We can switch to the next paper.
Question from Dr. Mustafa Jarrar.
Hi, thank you for the presentation. Actually, one thing I would like to, I didn't understand it, how you decide which semantic. So you use a classifier. I'm not talking about the lexicon or the data, the data source size. Is it the classification problem or?
You mean here?
Or rule-based? Yeah. Thank you.
Oh, okay, yeah. So I should explain how the English one was done first. So the English one was done by experts. So because we got like large connections in Lancaster across years, I think this was done many years ago. Yeah, before I thought about it. Yeah. So we relied on the English knowledge that was accumulated across years. And then when we reached the Arabic phase, all we did is we tried to match to that in order to enhance our matching. But in this one, we went to like pixel levels, providing like parts which
the original English is done with knowledge base. Okay.
We cannot hear your discussions.
So I think it's time to switch to the other, the next book.
Okay.
Thank you. Thanks.
احنا لازم نقطع بس كيف هذه؟
From the
Okay, Assalamu alaikum. Good morning, everyone. This is Sakhar Alkhereyf from CAC, Saudi Arabia. And today I'm going to present our work, AraNPCC. Sorry,
wait.
can you mute, please? Okay, thank you. So yeah, it's a new data set, the Arabic newspaper COVID-19 Corpus, authored by my colleagues at CAC, Dr. Abdulmohsen Al-Thubaity, Dr. Alia, Bahanshal, and I. So here's the outline. First, the introduction, the methodology, some corpus statistics. Then I will show two analytical case studies. The first one, the correlation between COVID terms appeared in the newspapers and the number of confirmed cases. And the second case study is the keyword extraction, and finally the related. So AraNPCC, we started collected AraNPCC in July 2020. Actually, Dr. Abdulmohsen started that. Felt like this is an important period of time, and newspapers are talking about the pandemic. So we wanted to see if there's language change, etc. We have collected more than 2 billion words from 7.2 million articles, covering the period before COVID-19, starting from January 2019 to the end of 2021. So it's a 3-year period. The texts were collected from 88 newspapers in 12 Arab countries. So first of all, we have to select newspapers of interest. I'm going to show the criteria next slide. Then we parse the website using the Python library Beautiful Soup. Okay. We parsed the article and we extracted the title, text, topic. If there's no topic assigned by the newspaper, we assign no class, and the date of publication. Then we store the article with the metadata as a raw text format, also as a pandas format. So we had some criteria to consider newspaper. First of all, it should be widely circulated and reliable source of news, something like Al-Ahram in Egypt or Al-Khalifa in Saudi Arabia. It shouldn't be just an online newspaper, it should be official. Second criterion, the newspaper should have an online archive from beginning of 2019. Third one, articles should have incremental identifiers, so we can just increase the ID in order to retrieve the second article. For these countries, UAE, Qatar, Lebanon, Palestine, it was hard to find such newspapers that meet the third criteria. For other countries, Libya, Mauritania, and Syria, we couldn't find newspapers meeting any of these criteria, maybe due to issues with infrastructure or instability. So here's the statistics distribution per country. You can see that some countries, actually just one, Egypt, has more than a million articles, while for other countries like Iraq, less than 10,000 articles. So total is 2 billion tokens and 7.2 million articles. For topics, some topics have more than 1 million articles, while others like science, technology, and reports have less than 10,000. Collect data from 2019. No, everything. Yeah, but it covers the period of COVID-19, before and after. Go ahead. No class if the newspaper itself does not assign any topic. Some news articles have others. Oh, yeah. Or maybe Rai. But some newspapers don't assign. Okay, so what can we do with AraNPCC? There are many tasks can be done using the corpus, first of all. retraining language models, topic modeling. Also, we can perform corpus spatial temporal analysis. And in this presentation, I'm going to show two case studies. First one, how the media responded to the pandemic. Second one, some keywords analytics. So in first case study, we analyze how the media responded to the pandemic by investigating correlation between the number of confirmed cases and mentions of COVID-19 terms. And we used three metrics to study correlation: person, Kendall, and Spearman. Each metric has different assumptions about the data. For example, person assumes that the data is normally distributed. And for the number of confirmed cases, we use the data provided by the Johns Hopkins University Hospital. They collect the data from official resources like Ministry of Health. And for mentions of COVID-19 terms, we use two words: COVID, which is also COVID, Corona, which is also. And then we compute the per million ratio of PM per country and month. So what we do for each country, we compare two time series, length 36, because we have 3 years, 3 times 12, 36. Okay, so here's the correlation results. Saudi Arabia has the highest correlation results for all metrics. Then Oman is the second for person. Also Bahrain is second when you consider Kendall and Spearman. Algeria is third in some metric or fourth. So the results show that scores show positive correlation between number of confirmed cases and mentions of COVID-19 terms. We found that some countries have mentions of Corona even before the pandemic started. Actually, first confirmed case in the Arab world was in February 2020. But when we dig deeper, we found that it's not the COVID-19, Corona COVID-19, but the other Corona, which is the MERS virus. However, the PM value was insignificant. The highest was 84 per million mentions in Saudi Arabia, actually, in Saudi Arabian newspapers, which Saudi Arabia has the highest number of confirmed MERS cases at that time. Okay, also we did another study. We compared two countries, Saudi Arabia and Algeria. Selected Saudi Arabia because it has the highest correlation scores. Algeria's second highest. We skipped the GCC countries. We wanted to diversify the regions. So what we did, actually we tried to see if there's correlation between mentions of COVID-19 related terms in Saudi Arabia and Algeria, as well as the correlation between number of confirmed cases. And this graph, the dotted lines represent new cases, and the solid lines represent the number of mentions of COVID-19. You can see here the peak for PM values around April 2020. For Saudi Arabia, the highest or the peak of COVID-19 was in mid-2020, but for Algeria was in mid-2021. You can see that the solid lines, they almost perfectly correlate, while for the dotted lines, they correlate, but not as the solid lines, which are the mentions of COVID-related terms. So here, the correlation. Yes. Yeah, you can. Yes. Yes. Yeah. Yes. That wasn't in the previous one. Yeah.
But yeah, in the previous one.
Yeah.
But in the newspaper, they may talk about COVID in a denial way, so saying we don't have COVID. So have you looked at the sentiment in the basically in that sentence that is referring to COVID or Corona.
Yeah,
So
that's
the correlation, yeah, can be very high,
yeah.
but the newspapers can be denying the existence.
Yes, but they're still talking about COVID. I mean, that was the goal, even positively or no, but we didn't do that.
Possible.
Yeah, that's a good way. Yeah, you can see that, yeah, for terms, we have almost perfect relation between number of terms in Algeria and number of terms in Saudi Arabia per million. And the second line is number of confirmed cases in each country, relation between number of cases in each country. So it's almost perfectly correlated. For number of confirmed cases, there's positive relation, but this the first case. Okay, the second case study was keyword extraction. The goal was to identify hot topics in 2020 and 2021. To do so, we need primary corpus and reference corpus. For primary corpus, we used the year 2020, 2021. For reference corpora, we used just the year before. So in case of 2020, it's 2019, 2021, it's 2020. So again, we focused on two countries, Algeria and Saudi Arabia, just to be consistent with the previous case study. We used log likelihood to extract keywords. So here I'm going to skip the details about log likelihood. Then when we compute the log likelihood, in order to consider a word to be a keyword, first thing, it should have value greater than 20, greater than or equal to 24. Also, frequency of the word in primary corpus should be greater than or equal 20, and the ratio of word in primary to reference should be greater than 10. Here, the number of extracted keywords. Generally speaking, Saudi Arabia has more keywords than Algeria, and 2020 has more keywords than 2021. And let's see some examples for keywords from 2020. From Algerian newspapers and Saudi Arabian newspapers, the words in black represent COVID-related terms, like corona, virus, COVID, etc., quarantine. For non-COVID-related terms, in Algeria, mainly about political figures. I think they are member of the Algerian cabinet. Also, there was mention of Semolina or Samid. I think there was food crisis at the time. For Saudi Arabian newspapers, you can see mentions of G20 when the country hosted the Group 20. Mentions of Biden, for instance, the US president. Okay, so most keywords in 2020 in both countries are COVID-related terms, and classify them into disease name, disease cause, or countermeasures. For 2021, now we have less COVID-related terms, but for COVID-related terms, you can see new words like the variants of COVID, Delta, Omicron, the word variant itself. You can see new words like vaccine, etc. And the most keywords are not COVID-related words, not as in 2020. Okay, some related work. I'm just focusing here on the most relevant work. OSCAR is one of the largest, perhaps the largest Arabic corpus. It was crowd from the web. Unlike our work, it's just from newspapers. Arabic Web 16 is another web crowd dataset. Text Arabic corpus is similar to our work in that they have the metadata, topic, time, country, and source. ARA1010 is also another large dataset. It covers both NSA and dialects. GigaWord is also another corpus, which is also from newspapers. However, it's licensed, unlike our work, which will be freely available for these To obtain the corpus, please feel free to contact us on email. And yeah, thank you for this. Any questions from the remote attendees?
So the online audience, do you have any questions, please? I just have a question regarding why did you put your email to get the corpus? Why not putting it in a repository and making it like what Dr. Al-Jarrar has done? He has a form that you can fill, then there will be a communication with the expected benefiter of the corpus itself.
Yeah, it's good to have to put it somewhere, but I think we had an issue with the size. Put it somewhere. Also, copyright, it's another issue. We try to avoid.
I think you can host it on Hugging Face now for free, up like 100 gigs.
Yes.
You can host it for free there.
Yeah. Actually, we put it temporary on copyright. Yeah, copyright still an issue.
My question was, did you notice any like dialectal Arabic text in each country? Like, I know that newspapers usually write an MSA, but is there like dialectal content that are probably existing in some newspapers?
It wasn't obvious. I mean, maybe there's, but we didn't see any of that.
Sir, we have corpus of 500 million tweets collected from different countries across the world. They have Arabic, English, Chinese, Japanese, many languages. You can contact Muhammad Nouran from CF-Arab-ESL. 500 million tweets related to comments.
Yeah, you mentioned that you have topic modeling. Is it the topic provided by the newspaper, or is it something like NDA?
From the newspaper. Yes, it's like a tag.
So it's a set of tags provided
Yes, provided by newspapers. Yeah.
So I think we need to switch to the next talk. It will be online, right, Dr. Hind?
No, it will be, I'm not sure it is written in person. If Kathrein is here,
Let me close this.
Kathrein is online. So Kathrein, do you hear us? She doesn't look online, just the name. Do you have her in person?
One more time. So if you have a presentation and you want to use my laptop, you can send this email.
If you are speaking in Jira Hamdi, I didn't hear you.
So,
Can you repeat
okay,
it?
so
Please?
if you want to present online using my laptop, you can send your presentation to my email. Okay. This for in-person presentations. Thank you.
It will be in person. Okay, excellent. So, thank you.
Assalamu alaikum, everybody. This is Kathrein from University of Gothenburg in Sweden. I'm gonna present my work. So the paper is a comparison. It's a work about comparison. So yeah, so it's pre-trained model or feature engineering, the case of dialectical Arabic. So it's paper about comparison between different model and approaches. The work is done by me and Stergios and Simon from the same university. Yeah, so the agenda, first of all, I'll talk about the objective, the dataset I've used, my experiments with 3 approaches, and in the final, some comparison and the results. So the objective of this study is to make a comparison between the most well-known and most commonly used methods in NLP recently, in order to test their performance using different corpora, different data set. And we take 2 NLP tasks as case studies, dialect identification and sentiment analysis. Actually, this work is part of my PhD, and in my PhD, I work on dialect identification and sentiment analysis, so I did both of them in this paper. Well, I'm gonna compare 3 generic classes of models, the bidirectional encoder representation from transformers, which is called PERT, and I chose the 3 PERT. It's called multilingual PERT, the Arabic PERT, and Twitter Arabic PERT. Also implemented a classical deep learning architecture, which is LSTM with the pre-trained word embeddings. And finally, I've tried also the traditional machine learning models with feature engineering. So for dialect identification, I've chosen 3 data sets to work on. The first one is BEDIT, which consists of 6 dialects from Arabic different countries. We have Shami, it consists of 4 dialects from the Levantine area, and we have also Madar 6, which have 6 different dialects. And they have also various total sizes, varies between orange between 33,000 and 66,000 instance or document. For sentiment analysis, we also have 3 different corpora or data sets. The Arabic Twitter sentiment analysis data sets, which contains 22,000 tweets. The 40K data set, which contains 40,000 Egyptian tweets, and the Arabic sentiment tweets data sets, which also contains Egyptian tweets. And it's like small corpus, 2,500 tweets. For all the experiments, I used the accuracy, the Matthew correlation coefficient, and the F-score. So we have like 3 measurements for the performance. Yeah, the first experiment I've done using BERT for dialectical Arabic, and as I've said, I used these 3 versions of BERT. The first one, which is proposed by Google, the multilingual BERT, and it was version 2. This BERT contains the top 100 language used in the world, with the largest Wikipedia content. And in this version, they used modern standard Arabic because like from Wikipedia, so it's MSA. The second one, it's Arabic BERT. It consists of, they have proposed 4 models of different sizes. They have large, base, medium, and mini. So I used the base model for the experiment, and it contains 8.2 words from the Oscar dataset, and it mostly contains MSA with some dialectical word. The last one, I've used Arabic BERT Twitter based, so it's mainly consists of Twitter dialectical word and some MSA word. In the second experiment, I've implemented approach using LSTM, but it's not so complicated. So I have pre-trained Arabic word embedding layer, and I've used Arabic as a pre-trained word embedding for Arabic. It's followed by LSTM layer with 70 nodes and a dropout of 25%. Then we have fully connected dense layer with 30 nodes and the last fully connected dense layer, which is the last classification layer. And the number of classes, it depends on the data set. So for dialect identification, as I've mentioned, we have 6, and 4 output classes. And for sentiment analysis, actually, I only apply binary classification. So is it positive or negative? This is some settings for the LSTM baseline. Okay, and the last part of the experiment, it's about feature-based classification. So in this part, we implemented some feature engineering depends on language model. So I have word gram features using unigram, bigram, and trigram. And we specify the transformation weight for the word gram features and set it to 8. We have character gram features regarding to word boundary and without word boundary consideration. And we also set some transformation weight. For the character for the character gram features, we have like different grams from like range for bigram to 5 grams character features. We did actually 2 experiments for this part of feature engineering. So one of them based on SVM machine learning models, but the second one, we have this feature engineering layer, but followed by a fully connected classification layer. So here we want to test the performance of feature engineering. This is the result for all of the experiment I have done. So this table shows the experiments and the performance measurements for all the experiments regarding the dialect identification task, the name of the corpora, and then all of the methods I have used. And it's very clear that the Twitter pairs outperform all of the other approaches. But we can see that feature engineering methods also can compete Twitter pairs with very, like we can say it has like a close results or close performance to a Twitter pair. The LSTM is the worst. Maybe this is due to unbalanced data set, due to the nature of deep learning models, that it needs a lot of settings, and sometimes it should we have to make like a lot of adjustments and complicated networks. So it's not easy to fine tune the deep learning network. Maybe this is clearer than the table. Here we can show that Twitter pairs for the 3 corpora outperform all of other approaches, but the machine learning models with feature engineering and SVM model also get a high performance. For sentiment analysis, we get higher performance. It's due to the number of classes. It's only 2 classes, so it's a binary classification problem. Also, we get that Twitter pair outperforms all the approaches, and also the machine learning models with feature engineering get higher performance here. This is also from the chart. We can say that multi-pair here, it doesn't work well, maybe because it works, or I'm sure it works with MSA and our data set mostly about dialectical Arabic. So what we can say now that the LSTM model is the worst performance model, maybe because the problem of out of vocabulary when we tested it was from 30% to 70%, so it's very high. And I didn't try any other word embeddings for Arabic. The network also for LSTM, it biased toward the majority classes, so it's affected by the unbalanced data sets like Shami. The Twitter Arab-BERT outperforms all of the model for all of the corpora in both case studies, the dialect identification and sentiment analysis. So because of the time, let's skip here. And yeah, so the main objective of this study was to have a comparison between these different approaches and using different corpora. And I want to know what, if I want to choose the model, so what is the best model for our problem? To conclude, we can say that there is nothing called the best model for a task, but there are many factors play a role to choose the model. Some of these factors are the size of our data set we're working on, the sources, the quality of the data, and if the data is balanced or unbalanced, whether the corpus contains MSA, so it's one language, or different dialect or different languages, like the dialectical Arabic, the number of classes as an output. And that's it. Thank you.
Thank you, Kathrein. From the virtual attendees, do you have any questions?
So basically, I was wondering if looking at the embedding space of the dialects, did we notice that some dialects are really near to each other? What's the difference in the embedding space? Have you looked in this or not? Because I wonder if we are mapping the embedding space, and for example, Algerian should be near to Moroccan somehow, and then our Egyptian Arabic should be some space, but I think the dialects should be narrow in a space for some dialects, right? So have you been looking at this?
I understand you, but no, I didn't.
Okay.
Yeah, but actually I have another study about the lexical distance and the similarity and differences between Arabic dialects, so maybe it can help.
Yeah. Thank you.
So any other questions? There is a comment from there.
Yes, Jack, hello?
She wants you to check the use of camel BERT. That includes dialectical data. This is a comment from Huda. Okay. I think we are done.
Thank you.
Thank you, Kathrein. Now we switch to the
No, it's
virtual
So, Dr. Hand,
presenter.
we have a question from Dr. Jack.
Okay.
Yes, Jack Halpern from Japan. We are working on a very large-scale Arabic dialects database, and we're working on Hijazi as one of the dialects. I was wondering if you know of any resources, or what do you know about Hijazi? Can it be converted? Can you use another close dialect to convert into or out of Hijazi dialect?
Actually, I don't have any experience about Hijazi dialects. Yeah, so I don't know.
But you don't work with Saudi Arabian dialects? Saudi Arabian dialects, you don't work with them?
I think there is a paper about the Najdi dialect after 2 papers from now. And so can you stay tuned to this paper and we can answer your questions.
Okay, thank you.
Thank you. Okay, thank you, Kathrein, again. Let's switch now to the virtual presenters. We have our presenter, Shatha Al-Hakami. Are you there, Shatha?
Yes, I'm here.
Can you upload your slides now? Her paper will be about a context-free Arabic emoji sentiment lexicon. The floor is yours, Shatha.
Yeah, but I can't share my screen.
There is a button called share screen. It is green.
Yeah, but I think it says I can't start sharing screen while other is sharing their screen.
Can you, Engineer Hamdi? Okay, excellent.
Okay. So. Okay. Can you see my?
Yeah. Yes.
Okay, so thank you, Dr. Hind. Hello, everyone. This is Shatha Hakami, and I'm here to talk about our context-free Arabic emoji sentiment lexicon. This is a joint work with Dr. Robert Hindley and Dr. Philip Smith from University of Birmingham. First, I am going to give a brief overview of the motivations that lead us to conduct our lexicon. But before I proceed, I would like to clarify a point that based on the Oxford English Dictionary, Merriam-Webster Dictionary, and others, the words emoji and emojis can both treated as plural indications for the noun emoji. Therefore, in the following slides, you will see the word emoji is used for both singular and plural indications. So why emoji? Emoji have become very popular in the recent years. They are usable, communicative, figurative, and rich in meaning, which make them very common among users of smart devices. Understanding how emoji interpretation varies between readers is not only an interesting academic problem, but it also has many practical applications in the design of tools for interpreting and using sentiment. So emoji sentiment interpretation is not universal. It has been proven that users vary in their interpretations of the sentiment expressed by emoji, even within the same context. These interpretation differences are attributed to several factors, such as sender-receiver relationship, user cultural background, the variety of emoji renderings across platforms, the user familiarity with the environment of the social media platform where the emoji exist. There are many emoji sentiment lexicons for different languages, such as English, Japanese, some European languages, but less for Arabic. Most of the Arabic studies that used emoji in their work have agreed on the need for an Arabic-specific emoji sentiment lexicon, and they recommended constructing such a lexicon upon which to build their further work. In this work, we targeted people from Arab cultures and made them labeling a set of emoji out of non-textual context. This has formed a context-free emoji sentiment lexicon constructed of 1,069 emoji annotated with sentiment scores and labels. We made this lexicon available for research use. Our methodology is based on the following. First, we recruit 53 Arabic native speakers, females and males. The participants were from 7 Arabic regions, including Gulf, Egypt, Levant, Sudan, Maghreb, Iraq, and Yemen. Some of the participants were directly asked to volunteer, while others were hired via Khamsat. Then we selected a collection of 1,034 emoji from an already existing emoji, Arabic emoji sentiment lexicon. These emoji have been extracted from 14 different Arabic datasets that contain tweets from Twitter platform. The tweets have a variety in dialects, aspect, topics, and emoji usage. We also have added 35 extra emoji that we believe are important to be included in our lexicon. After that, we set up an annotation interface containing sets of 5 forms using Google Forms. And the forms contain all the 1,069 emoji. We chose Abel platform emoji renderings and upload them to the forms as images. We also converted each emoji characters into a UTF encode and used it as an emoji identifier within the forms. Also, some forms were provided with emojis official Unicode names as emoji descriptions. The forms have a section where we collected some demographic information about the participants. This includes age, gender, religion, and if they suffer from some health issues like dyslexia and color blindness. We also asked about some technical setups like the used device, operating system, and web browser. After the annotation task ended, we asked the participant to share with us the most 5 emoji they usually use. And if the inclusion of the emoji names was important or not. Regarding the annotation task, we provided each participant with 5 URLs of the Google Forms, and we asked them independently to complete them within 7 days. Each form has 213 emoji, and the participants were asked to select one of the following options. Either very positive, positive, slightly positive, neutral, slightly negative, slightly and negative, very negative, mixed sentiment, and I don't know. These presented as radio buttons. The annotation process was estimated at roughly 21 seconds per emoji, which is about 10 minutes per form. And the whole data collection task was completed by all participants over a period of 6 weeks. To validate the annotation of each participant, we used recall and K-alpha measurements to test each annotator's self-agreement. These measurements were applied on the 3 sentiment label norms, negativity, neutrality, and positivity. The groups of emoji in the table here were chosen for negativity, neutrality, and positivity self-agreement tests. So if either the recall value or the K-alpha value is less than 0.75, then the annotator is considered as unreliable, and her or his annotation results are invalid. Hello? Yeah. Can you hear me?
Yes, continue, please.
Okay. To calculate the emoji sentiment scores, we first unified the group of sentiment labels under 1 sentiment norm as 1 sentiment label. Then the frequency was identified with which each emoji is associated with human sentiment annotation labels, negative, neutral, and positive. Afterwards, we used the Laplace estimate to estimate the probability and form a discrete probability distribution. And finally, we compute the sentiment score of the emoji as the mean of the distribution. Here is a small example. For example, let's assume that we have 3 annotators to annotate 3 emojis. And we get these annotations from them. For the first emoji, let's assume that there are 2 negative annotations and 1 I don't know. So we disregard the I don't know and only consider the sentiment annotations, which are 2, and calculate each sentiment independently. So here we have 2 negatives, 0 neutral and 0 positive. For the second emoji, for example, we have 3 sentiment annotations that are considered. So we calculated as the following. Then we use the Laplace estimation based on this formula to calculate the probability distribution. And we end up with these, for example, these scores. Finally, we compute all the mean of these distribution by just adding the minus of the negativity with the plus with the positivity to get the final score. For example, the first emoji is minus 0.4, and the second is 0.5, and the last one is 0.
2 minutes, Shatha, please.
Okay. We also converted the scores to labels using this sentiment scale. For example, any score under the minus 0.062 is considered as negative, and anything above or any score above 0.026 is positive, and anything between these numbers is neutral. As a result of demographic data collection, we have 52 females and 48 males. 60% of the participants are between 25 and 34 years old. 2% were dyslexic, and majority of them, or most of them, almost everyone are Muslim. They all are educated, and 70% of them were in their home country. Regarding technical setup, there are 74% of them using a mobile phone. They prefer iOS operating system, and they also prefer Google Chrome as a web browser. The most preferable emoji or frequently used emoji was the emoji with tears of joy. And they, regarding the inclusion of the names of the emojis, there were 53% of them articulated that they were partially important for some emojis, and they are not important for others. And 5% of them consider it confusing. Finally, for the sentiment annotation, Arabic user, perhaps like other users from different culture, agreed on specific sentiment for a subset of emoji that obviously present the sentiment. For example, the concept of motherhood is positive, while the concept of prohibition is negative. However, there are some Arabic culture specific indications for emoji, like black color, which indicates negativity in Arabic culture, and rainy weather, which is considered as positive in Arabic regions. Also, there are many animals that indicate positivity in Arabic culture, like horse and lion, while other animals like snake and pig considered negative. Besides, since majority of the participants were Muslim, Islamic religion has a very impact reflected in their sentiment annotation. For example, the emoji that represent Islamic religion rituals annotated as positive, while alcoholic drink emoji annotated as negative. Also, all Arabic countries' flags were annotated as positive sentiment as a sense of national affiliation. Finally, as a future work, we intend to make the resulting emoji sentiment lexicon more fine-grained for further focused and detailed analytical studies. And it would be interesting to compare this context-free lexicon with context-sensitive emoji sentiment lexicon in Arabic language. The lexicon provided in this study may also be informative for Arabic sociolinguistics researchers interested in emoji usage and sentiment expression on social media by Arabic users. That's everything. Thank you.
Thank you, Shatha, for this interesting talk. Let's take one question from the virtual attendees, and then we switch to the in-person for the sake of time. If we don't have any questions from the attendees, I have only one comment regarding the annotation process itself. As it seems, it looks like it was done manually without using any platforms. So like, let's say, Appen or Toloka or any other platform. Is that correct? Is my understanding correct regarding the annotation process?
If I understand the question, actually we used Google Forms as the platform for annotation. So Google Forms, I think it's considered as a platform for annotation.
But still, it doesn't, I mean, automate and aggregate things. You need to do it manually.
Yeah, you're right, yeah.
Okay, excellent. So Engineer Hamdi, back to you.
This is Mahmoud. I have a question, please. I don't know if the speaker can hear me.
Yes.
Oh, okay, all right. So my question is simple. So I'm just going to say is, because Arabic is spoken by more, I mean, I know the Muslim population is higher, but it's spoken by a great variety, especially when you go to like other countries in the North of Africa, for example. So what did you do to make sure that your experiment is inclusive? I know that you collected things like gender and religion, for that one, but how do you ensure inclusivity in that case, just to make sure that it's not biased towards one like group, for example?
Actually, the short answer is by increase the number of the annotators and make more focused lexicon for each reason and each like small group. This is what it's like. How can I say it? Accumulated work, so we can divide it by subworks and then combine it together. Because it's very huge. Actually, we can't do it as one study or project.
Actually, this is Nizar Habash. I have a question for you. Thank you for this work. It's wonderful to have this resource. So, you know, it's a question about your last slide where alcoholic drinks are marked as negative. And I'm just curious about, is there kind of a missed subtlety here between associating something with being negative or choosing never to use it, right? Like because you said, you know, they're Muslims, so they don't drink alcohol. Right. That means they probably would never use it, but that doesn't mean necessarily it's negative, right? Like they may see a Christian Arab friend celebrating something with a glass of champagne that is not negative. So I'm curious, what did you do anything in your survey where you distinguish between this has a strong associated negative? Like I buy the snake, for example, that makes sense. But then the champagne, I mean, I don't know, maybe they just don't use it as opposed to they think it's negative. Do you understand what I mean?
Yeah. Actually, to be honest, there are other emoji other than this mug, beer mug, that annotated as neutral, positive, and sometimes negatives. But this one, so all the annotators was mostly agreed on this one as a negative. I think maybe because the concept of the alcoholic or something, maybe for health issue or regarding the health or something. But I haven't done any like detailed analysis on that and do like a very detailed survey regarding that specific concept. So yeah.
I think Shatha, as you mentioned, you will put these emojis in context. So this will solve all these issues. We'll see the exact use.
Yeah, exactly.
And also, Engineer Hamdi has a paper about the emojis. The recent article has been published.
Yeah.
The use of emojis.
Another question, please.
Yeah, please. Go ahead.
Hi, thanks for great work. I have a question. So you said you annotate these emojis depending on the context of the tweets. So did you evaluate it in a task or work in another way around, like use these emojis to retrieve tweets and then evaluate these lexicons toward sentiment analysis tasks, for example?
Yeah, actually these emojis in this work have been annotated out of any context, so it's by itself, but we select the emojis, for example, where is it? We selected 1,000 from already existing emojis lexicon. So we didn't, we took it as it is from an already existing emoji lexicon, not extracted from Twitter, but they were extracted from Twitter. So yeah, so in this study, we didn't extract it from Twitter. We just took it as a list of emoji.
So thank you all for this fruitful discussion. Can we switch to the next paper, please? The presenter will be Amal Dawood. She will be talking about Sakhar, a Saudi dialect irony dataset. Amal, are you ready? Yeah. We cannot hear you, Amal.
Yeah, I'm ready. Can you see my screen?
Yeah, it's on now.
Okay. Okay, thank you so much. As you know, the key problem with detecting irony is the difficulty to recognize the implicit and indirect phrases which signifies to the opposite meaning. And detecting irony is considered as a major challenge in sentiment analysis. So for that, we in this work, we propose Sakhar, Saudi dialect irony dataset. First of all, we will have a short introduction and go through the content until we arrive to the discussion. In the introduction, we need to identify what irony is. Irony is the expression in which a person uses word that means the opposite of what intended, especially to be funny. Irony is broadly used to express individual opinions and feelings. Detecting irony is difficult since it's relative to individuals and various with different attitude and cultures. The main advantage, or one of the main advantages of irony detection task, is that it assists many fields, such as businesses, to get insight from public opinion regarding services improvement. Our main contribution in this work is to create a public Saudi dialect dataset of about 20,000 tweets with irony and non-irony labels. And we compared different neural network and machine learning models and report the best accuracy model. First of all, we have checked the available corpora, and the tables shown on the screen summarize the available Arabic irony dataset. So we can see that view dialectical dataset tackled irony and sarcasm detection, especially in Saudi dialect. Most of these dataset collected tweets using hashtags only. So in our work, we proposed a new Arabic dataset for Saudi irony tweets collected from hashtags, phrases, and words annotated by humans. So we collected data using 35 words. So we collected about 26,000 tweets. We used hashtags such as mushadu'a batahakum and which means joke or irony. And also we use some keywords that reflect to the irony or and some phrases also. You can find the rest of the 35 in our paper, but here's some examples. The data collection was for the last 10 years from the data collection time, which is from 2021 and from 2011 and 2022, 2021. Before we used the model, we first did some data pre-processing and cleaning for the data. So we need to remove the web links, we removed the white spaces, HTML tags, and so on. After pre-processing, we got about 20,000 unique tweets. So we used this clean tweet and we started the annotation process. In the first round, we have two groups of annotators. Each group will annotate the same tweets. So we have we need to get the agreement or disagreement of the annotators on the same tweet. So then we filter out the annotator disagreement and ambiguous. So we have the annotators annotate tweets into irony, non-irony, or ambiguous. So in the second step, we filter out the annotator disagreement and ambiguous agreement and took this disagreement, which was about 7,000 tweets, and we hired another annotators to annotate these tweets into only two labels, which is irony and non-irony. Finally, we have the tweets filled with labeled with irony and non-irony, and we measured it with the Fleece Kappa. We measured the inter-annotator agreement between the two annotators using Fleece Kappa, which is a statistical measure of agreement between categorical values. It's commonly Fleece Kappa is commonly used to measure the inter-annotators reliability of the annotation of the dataset. We got an agreement result of 0.54, which is a moderate level. But it's worth to mention that in the second round of annotation, we put back the emojis and the numbers, punctuations, also the non-Arabic words, because they clarify the tone of the tweets. So we can clarify we can understand the tweet and the tone of the tweet if it was irony or non-irony. because most of the annotators labeled with ambiguous for once they didn't understand the tone of the tweet. For example, here, which please guys give him a link, but without the number, it looks like a normal tweet, but with the number, it clarifies that this is an irony tweet. Also, here's an example of the non-Arabic language, of the importance of keeping the non-Arabic language and the punctuation in the tweet. Finally, we have about 8,000 irony, which is more than, which has about 10% more of on the non-irony class. And in this section, we conduct different experiments to set baseline system for the new data set. We started with a set of machine learning algorithms, then a classifier built using word embedding a vectorization technique with BILE-LSTM. Lastly, we tested a BERT-based model. We have split the data set into two parts. The first is the training set, which represents 80% of the data, which and the testing set represents the remaining 20% of the data. We have compared different models, and as we can see, BERT model or AraBERT model achieved the best accuracy. Since our data is unbalanced, we use the F-score to measure these data, and as you can see, AraBERT achieved the best model. Also here, we can see the F1 score per class for each model. Also, we can see that the AraBERT achieved the highest score in terms of irony data. As we discussed, the collected tweets are based on dialect Arabic, especially for Saudi dialect, and AraBERT achieved the highest result, following by the SVM model. The pre-processing may affect the meaning, but its main benefit is to remove duplicate tweets and normalize the text. As we saw earlier, that emojis, punctuations, non-Arabic words have a high fact on to understand the tone of the tweet. Also, it's unavoidable to collect tweets from another dialect or language, but since these keywords are commonly used in Saudi dialects, in addition to the fact that Saudi represents the largest number of users within the Arabic region on Twitter, as the statistic that Twitter announced in 2022. So based on that, we considered these collected tweets as Saudi tweets. And one limitation of this work is that since the ironic words and phrases are huge, but we are limited only to 35 keywords. More keywords may be included in future work. Also, we noticed that the misspelling words such as subhanallah give more ironic results than the direct ironic words such as tahakkum, or which means irony, or the hashtags that related to irony words directly. So we noticed that the misspelling words are intentionally used in the context of irony. So as I mentioned earlier, we relied on F1 score for evaluation purpose and to avoided accuracy. Another issue we found that is ironic tweet depends on the topic. So, for example, for the photoball or movies and so on. So annotators have this ambiguous to understand, or they couldn't understand the tweets out of context or out of its topic or the interest field. I hope you understand what I mean. Finally, the annotator's personalities and mood is another issue. So this could affect the annotation process. So to avoid that, we mitigated this issue by making multiple annotation rounds. So in the first round, we have two annotators annotating the same tweets and compare the agreement and disagreement. And finally, we annotate another or a third annotators to annotate the tweet after it. This is the end of our work. Any question? Thank you for listening.
Thank you, Amal. Thank you for this interesting talk. There is a comment, I think, by Abdurrahim. It is better to use Arabic model that has dialectical such as Marburg, Camel, Arab, Twitter, because Arab built using MSA data. This is a comment from him.
Thank you. But
do you have any?
We used already Arabert and
no, he means that the transformer models that has been trained on dialectical Arabic better than MSA. So this is a chance for improvement. Any other comments from virtual attendees? Yeah. Go ahead, Hamdi.
Yeah, we have a question from Dr. Jack Halper.
Yes.
Jack Halpern from Japan. You mentioned Saudi dialect several times. Which particular Saudi dialect are you talking about? We are working on Hijazi dialect, and it's very difficult to find resources. I was wondering if you have any resources, and what do you mean by Saudi dialect?
We mean what's that called, the white language. I mean the dialect that all Saudis used in general, not specific region. So we have some examples that collected the keywords from Hijazi, Najdi, and in general words. So we didn't use, or we didn't focus on a specific dialect. So we use the phrases and keywords that use in general between Saudis, that all of Saudis can understand. Does that answer your question?
Any questions?
So any questions?
I have two questions after.
Yes.
Okay, so first, how about thinking about other methods for data collection better than using the keywords explicitly? I am telling a joke now. I think we will have a lot of bias in data collection using specific hashtags. This is the first comment. Do we have other alternatives? And the other one is we have a shared task for detecting Arabic irony organized by Walid Magdi and Ibrahim Abu Farha from Edinburgh. I wish that you use your model and test on your testing data, their testing data, and also train on their data and test on your testing data, such that we can study the generalization of the models across different data sets. Thank you.
Thank you. We may consider it in the future work. Thank you.
Okay, thank you, Amal. Let's switch to the final paper in this session. Ala Al-Harbi, if you are there, please you bring up your slides. Ala will be talking about classifying Arabic crisis tweets using data selection and pre-trained language models.
Assalamu alaikum.
Alaikum assalam.
Can you see my screen?
Yes, presenting, yes.
Yeah, is it there?
Yes, it's present. Yeah, go ahead, please.
Okay, hi everyone. My name is Ala Al-Harbi, and I'm going to present our work titled Classifying Arabic Crisis Tweets Using Data Selection and Pre-Trained Language Models. It's done by me and my supervisor, Mark Lee, from the University of Birmingham and Taiba University. Okay, first of all, previous work showed that Twitter content is a valuable and accessible source of data about and provide that accessible source of data about crisis events. So unsupervised language models can be used to, classify such, tweets to find and extract crisis events and classifying them into different information types. However, the label data or label training data sets are not available or unlikely to be available in real time from current events, because obtaining sufficient human label data is time consuming and labor intensive So the unavailability of training data from a new crisis, it challenged such timely processing of the crisis data by the emergency responders. So one possible solution is to use data from historical events. Actually, previous work tried that and showed that supervised language models can use such historical data to classify or predict new crisis events. However, most of such supervised models do not perform well because of the out of distribution problem. Well, what I mean by out of distribution is the covariant shift. I mean by that the different probability distributions of input features across the training or the source events and the test or the target data. Data across the events, they differ in main two aspects, the topic and the language. For example, look at this, I mean, sorry for those, I mean, cannot read Arabic, but here I have data from the flood event, the Kuwait flood and COVID-19 pandemic and Beirut explosion. And this is, I mean, shows clearly that, I mean, the pronouns features here is completely different. I mean, here talking about the floods and rain and heavy rain and the civil defense, but in COVID-19, it's, I mean, all features about, I mean, diseases and the new cases, etc. While in Beirut explosion, it's related to, I mean, the hospitals and victims more, I mean, and for example, like blood, etc. I found that even, I mean, both from two events, even from the same type, I mean, like a flood and flood, can discuss, I mean, various topics. And this is different because of the name entity, the event, special aspects like the time, cause, the related entities, and the impact. And here is example, I mean, two flood data, and they have, I mean, different key features. One from the Grayat floods and the other from Hafr Batin floods, for example. The other aspect is the language. Events on social media discuss with varying levels of formality in different dialects, I mean, in case in Arabic, and sometimes, I mean, they use different, I mean, languages. So the problem here is that the supervised classifier's performance dropped on the test data if they do not follow the same distribution of the training set as many learning algorithms assume. Previous work showed that training on a domain similar to the target data results in a performance gains for various NLP tasks, I mean, particularly in translation. So our goal here is to improve the performance of the cross-crisis classifiers when I'm training on some crisis and testing on another, I mean, crisis, regardless of their type. I'm going to use as unsupervised domain adaptation. I mean that no label data is available from the current or in the new crisis. Here we propose to use a data selection approach to train a classifier on the best matching data for the target emergency event instead of using all multi-event source data. And we leverage the pre-trained language, contextualized language models that for two reasons. The first one is that they achieve the state-of-the-art results. And the other one is they eliminate the need of large data sets, unlike the classical deep neural network that need large quantities of a label data set. Here we defined a domain as, I mean, each crisis presents one domain. So a domain is defined as a data set that has been collected from social media for a specific crisis. In other words, each crisis data represents a distinct domain. And we consider two tasks. The first one is the relevancy detection. So it's a binary classification. Is this tweet is on topic or off topic, or relevant or irrelevant to that crisis? For the off-topic tweets, we find them, I mean, when investigating them, we find that most of them are advertisement, jokes, represent political views, or a related personal messages, or sometimes it's a post about a different crisis, because I mean we found that people tend to talk about other crises within the hashtags or the events of one crisis. So for example, discuss COVID-19, I mean within the dragon storm or flood data. So one crisis invokes discussions about the other. The other task is the information classification. So the relevant data will be classified into different information types like infrastructure damage, caution, affected individuals, etc. Here we present our multi-source data selection. First of all, we take all multi-source label data, and our selection is only done on the topic post. So we divide the post into on topic or off topic. We only select the most relevant data from on topic post, and we used all off topic posts because we have a very skewed data set and a relatively small percentage of the irrelevant tweets. And the other, I mean, reason is because I mean, we cannot predict what personal messages people or irrelevant messages that can be discussed within the event. So for the off topic, we found that some of them are related to other crises. We removed or filtered out all of these, I mean, both from the training data. And as we said that we perform our selection only on the topic posts. We use the key nearest algorithm to choose our instance level based nearest k algorithm to choose the most relevant or the most similar data set. Then we combine all the off topic and the selected data, and we form the training, I mean, data set. We use it to fine tune AraBERT or BERT model. Finally, we use that data to predict the target data. After that, we find out if using self-training with this, I mean, data selection strategy can enhance the performance or not. This is the algorithm that we talked about, so no need to go over it again. So. We perform our experiments on the Kwaik data set. It's available online. This is statistics about the data set. As you can see that there is, I mean, the data set is unbalanced, I mean, particularly for the binary classification task. We have most of the label data, I mean, from flood events. And we have one about COVID-19 and dragon storms, relatively similar to the flood and the Beirut explosion. And here, the distribution for the different information type affecting individual infrastructure and caution and emotional support and prayers, finally, the opinions and the criticism. Here are our results. First of all, we would like to, I mean, we used the leave one out strategy. That means one crisis as a test data and all other crises as a training data. And we experiment with different values of Al-Key, 3 and 5 and 10, to see, I mean, if choosing different, I mean, values can, I mean, affect the results or not. And on average, we found, I mean, first we compare the data selection methods with the first baseline, which is using all training or source data, I mean, to fine tune the BERT model. And we found out that on average, all the data selection methods perform better than, I mean, using all the data. I mean, despite that, it's the relatively small data set, I mean, it's compared to, I mean, using all of the training data. So it's not about the amount of data. I mean, it's, I mean, the quality of the data plays, I mean, an important role here. And we just, I mean, focus on the best model, which is key equal 10. And we found that on average, it's improved, I mean, both the weighted F1 score and the macro F1 score particularly in these three cases, which is the COVID-19 and the Kuwaiti flood and the Dragon storm. For COVID-19 data, for example, it's improved the results by almost 10%, and the weighted F1, I mean, sorry, for 7%, and for the Kuwait, the macro F1, it's been improved by 10%. And maybe the pronouns or obvious improvement is related to COVID-19 data. And then we compare the other baseline, which is using the self-training. We compare that with first with using all the data set, and then with our robust selection algorithm. And we found that it's relatively work better than using all data sets, particularly in these three cases. But it worked worse in the case of the Hafr al-Batani flood. And we found out the reason because some or many of the irrelevant or misclassified instances that's been added to the training data sets, it just damaged the performance. So in this case, it was, I mean, it works worse than using all the data set. For other cases, it achieved comparable performance. And the best performance is related to the COVID-19 data. And then we found that our data selection algorithms actually work better than the using of than self-training on this task, which is the relevancy detection. But the but not, I mean, in the case of the COVID-19 data. And finally, we combined the two methods together. So we explore whether self-training enhances the performance of the data selection models. So we combine the self-training strategy with the best data selection model, which is the key equal 10. And we found that combining them together achieved the highest score on the COVID-19 data, enhanced the macro, the weighted F1 by 12%. So, however, using just the the data selection worked, I mean, or achieved better performance for two events, I mean, two floods event, the Kuwait and the Hafr al-Batani. So we concluded that integrating self-training, I mean, for the other cases, it just achieved comparable performance. So we concluded that combining the self-training with the data selection is recommended when there is a significant distribution gap or shift between the source and the targets, like in the case of the COVID-19 data where self-training performed very well. This is because it shifts the weights towards the new events.
So 2 minutes, please.
Yeah, I'm about to conclude. So this is the results for the information classification task. So regarding this, we only, I mean, experimented with the case that key was assigned to 10. And so this task, just I need to say that this task has been assessed separately. So we suppose that our method is, I mean, successfully can detect all and filter out all irrelevant posts. And I need just to categorize the crisis related posts into predefined information types. And so generally, using data selection, I mean, improved the results in several cases, achieved comparable results on the others. But self-training, I mean, also worked very well, but comparing the two together, I mean, did not improve the performance at all. So we recommend to use the data selection instead of self-training because using self-training damaged the performance for one cases, which is the Kuwaiti flood. And I think, I mean, we looked at the errors and found that many of the tweets that related to affected individuals in this event have been misclassified. So to conclude, this paper, I mean, proposed a selection-based multi-source domain adaptation approach to identify crisis tweet messages for new events. And we demonstrated that selecting a subset of data that is semantically similar to the target event for fine-tuning BERT language models showed promising results and outperformed two baselines, which is the training on all data in both tasks, and it's work better than self-training on a relevancy detection task. So that's all, and thank you for listening.
Thank you, Ella. Thank you very much for this interesting paper. We are about to go to the lunch break, I think. One question from the virtual attendees and back to you, Hamdi, for any questions from your side. So any comments from or questions from the virtual attendees? It seems that no one is asking. So back to you, Hamdi.
Thank you for the great work, Ala. So I have a few questions. So first, if you go back to the distribution of different tasks for the COVID, for the Kuwait crisis, etc., we have, I expected actually to find a huge number of tweets related to COVID. And in your table, you find very few tweets like this.
Sorry, cannot hear you. Can you say it again and raise your voice?
So the table that shows the number of tweets for each crisis.
Yeah, the statistics.
So this one here. So why do we have a small number of tweets? Let's say COVID, we have millions of tweets. Why do you have here small number of tweets? And also in other crises, we have very small number, like Cairo bombing, only 706. Some of the tasks here have few number of tweets. Do you have a reason for this?
Well, we explained that on our previous paper, Kawaris. And actually, when we collected the data set, we use, some keywords to collect the data. So we expect that more relevant posts than irrelevant posts. But actually, after collecting the data set, we filtered out the duplicates and almost near duplicates. And so we have here a different, and only consider the distinct tweets. And here we have a different number, and we found out for some events, only, a few instances were irrelevant, and most of them, they're relevant. And one reason for that, we in our annotation task, in the instructions, we made it clear that opinions on the same events are considered relevant as not irrelevant. Only the opinions that talk about different topic. So maybe that's different than our work that they considered all opinions, tweets, as irrelevant. Here, we have just the skew distribution, regarding the two classes. Is that, I don't know if I answered your question or got it.
The other question is, so is the task to predict whether the tweet is, let's say, related to Kawaris or crisis or not, or you want to predict the label here, whether the tweet is affected individuals or caution or emotional support? What's the task? Is it binary classification, or you need to predict the label, the fine-grained label? Thank you. So did you hear me?
Sorry, that's the question about why.
So yes, the question was about the task, whether you want to predict whether the tweet is important or not, let's say, versus the fine-grained detection of the label. I want to predict whether this label, this tweet related to emotional support or caution or infrastructure, something like this. So the definition of the task.
Actually, the two tasks should be, done sequentially. But here in this work, because we are not, we would like in the future to just evaluate the whole framework, I mean, and combine the two tasks together. But here we are only interested in, I mean, evaluating them separately. But actually, I mean, the first steps should be to filter out all irrelevant messages, or I mean, and the other one is to take the relevant messages and to classify them into different information types to just support the humanitarian efforts and the crisis respondents, etc. So here, I mean, the purpose of the final purpose is to say this tweet is about infrastructure. And by the way, the second task is a multi-label. I mean, a tweet can have different, I mean, labels. It could be discuss, I mean, two topics.
Thank you so much. Thank you.
Thank you.